Good morning, students. In this video, today we discuss about area of computation, Unit 1. Unit 1, Introduction. Today discuss about finite automata. Finite automata is nothing but it is a machine which is implemented in the system approach in a simple computations model. So we implement each and every objects, every work our machines are worked as a in terms of set of predefined functions. Similarly, we are called for finite automata, which is implemented in the realistic manner. Now, what are the points we discuss now? In this video, we discuss about deterministic finite automata model, how it will be work. These are the points only we are discussing. Deterministic finite automata definition, how it will be work, how it will be constructed. And similarly for non-deterministic finite automata, how it will be work and how it will be executed. The finite automata is a model, it is a machine, it's everything will be controlled by control unit. How the CPU will be executed, how the system will be evaluated, the executed, the central processing unit, CPU is the major part of the computer. Similarly, the finite automata is having the points for control unit is the major equipment or major part of the automata. It will be control the entire automata operations. The control unit read the input from the input tab. So in this input tab, which contains the input tab which having the represented in terms of individual cells, each and every cell occupy one character. The inputs are read with the help of the tab gate by the control unit. So tab gate movement will be presented only one direction, that means left hand side to right hand side movement. And next, the tab gate initially points the very first character of the input. So the control unit which contains finite set of states, finite automata definitions. The first element will be the finite set of states which contains the control unit. Second one, it's exactly one state at a time. So compulsory at a time, only one state only it will be processing. So it's having the n number of states. Out of n number of states, the machine will be working by stage. That means state by state it will be working. At a time, current situation, the machine will be states on one particular state alone. That is a call for exactly one state at a time. Second, third point, it contains the starting state of the machine. Compulsory it will be indicated as a starting state. Similarly, for a set of final states are possible. Maybe the one final state or more than one different final states also possible. So it depends upon the language, the final state will be varying. So that single state, multiple n number of final states are possible. The input tab is to store the input of the DFA that can be any length. So the length of the input string maybe is not a fixed one, it is a variations from language by language. There is no condition for the specific length size, but here it's having any length size. The tab gate is move the right hand side one cell at a time. So tab gate is initially pointed as a very leftmost end of the given input. The tab gate once first input is read, moved to right hand side one position. At a time only one position is only moving, not for more than one different positions. Once the second input is processing, immediately tab gate move to next input reading operations. So tab gate move to right hand side one position. So how the finite automata work? So read the input string from the tab. First one, determine if the input string is in a language or not. So corresponding input characters which is present in the language or not, it should be verifying. If it is available, it will be goes to yes or no. In case of yes means the automata move to final state. Otherwise, the automata will not be moved to final state. It will be present in between any other state. How does the finite automata work? At the beginning, at the starting of the finite automata means the initial state. That means start state will be presented. And its tab gets points to very first cell of the input, which is input is in the input tab. For each and every move of the finite automata, what are the steps we are carried out in the automata processing means? Read the symbol under its tab gate. So read the input with the help of the tab gate, the input will be read from the input tab by the control unit. Next, change the states according to the transition diagram. So it's the corresponding diagrammatic representation we are representing. According to the transition diagram, the corresponding based on their input, the changes in their states to the next state determined by the symbol read from the tab and its current state. So the input will be read based on the two parameters. That means the input processing, that is transition representations will be presented in terms of two representations with the help of current state of the automata and what is the input is read. Based on these two values, automatically we constrain or identify the next state. Once inputs are read, the move its tab gate in the right hand side one position. That is our process. So at beginning level, each and every move. This is our automata works. How does in a finite automata stop working? When it will be stop working? When it's read all the symbols on the tab. So once the entire input will be completed, we can stop the process. Then it's give the answer of the input in the specific language. That means according to the answer is yes or no. If it is yes, if it is last state is final state. Answer is no means it's if the last state is not final state. So in the automata, we represented as a starting state, final state, intermediate state, whatever it is. The final states are represented in terms of double circle manner. In starting state with the help of one incoming edges with start symbol as a label. So in this way, the stop working. So the finite automata, when will be work? When will be complete? Automata is complete to entire input is read all the input symbols. After the reading all the input symbols, the automata moves to final state. That means yes or no is two answer. If it is yes, it goes to final state. If it is no, it's not in the final state. It will be present in between any of the states. Example of DF. So this is my diagram. State yes and state F will be presented. State yes and state F. If in this particular diagram, state yes having one incoming edges, that will be only one coming without any input symbol, that termed as S is starting state. If S is read the input 0, what is the next state? S is the next state. Suppose the X is read the input 1, automatically control transfer to next state, that will be F. And similarly, F having the state of 0 input, it's having the self proof, the next state will be F. At the same time, F is read the input of 1 means is move to next state, goes to yes. So this is representation is transition diagram. So this transition diagram will represent as it's look like the ordinary graph. So graph having the nodes and edges. Similar concept. Here nodes are represented in terms of states and edges are represented in terms of transition of their input. The corresponding table representation. Here how many states are there? Few, nothing but state A is the input. So In case of S, 0 inputs, mapping function of S comma 0, mapping function, state comma input. So what is the state? S comma 0 means what is the next state? Yes, that is a start target. Similarly, mapping function of S comma 1 goes to F state. So and F is 0 input goes to next F state. Similarly, F comma 1 input means goes to S next state. There is transition function. This is transition function. How to define a DFA? Finite automata will be defined with the help of 5 tuples. First one, a set of states, capital letter Q. That is why called as finite automation. Next, a start state S, which is in capital letter Q. Compulsory, it is presented the one starting state is present in the automata. That particular starting state is one of the state in the capital letter Q given finite set of states. Next, a set of final states, capital letter F will be represented. That is also one of the states in the finite set of states. So, in this particular automata, a set of states we represented in terms of capital letter Q, which contains all the states in the given automata. And starting state is some state. For example, we consider starting state is S means S is also in capital letter Q. Similarly, we consider final state will be in terms of capital letter F set of states means F is also is present in the capital letter Q. And next one, input alphabets. Input alphabets means given input characters. So, for example, previous example called as input sets 0, 1. In the transition, the input symbols are represented as a label 0, 1. That we called as input alphabet or input set. Next one, the transition function in terms of mapping function of state comma input. Corresponding state, what are the transitions will be presented. That will be represented as a transition function. So what is the usage of transition function? Means the transition function is used to determine the next state of the automata based on current reader input and current state of the automata. It depends upon the current state and input. The next state will be determined. Maybe the next state is either the same state or next another different state. One more important point in DFA means which contains exactly only one next state in the each and every transition. For example, the mapping function of state comma input is equal to exactly one state is the output. That's why the automata is called as deterministic finite automata. This is called as 5 tuples automata Turing machine finite automata M is represented is a collection of 5 tuples. The 5 tuples are capital Q, comma sigma, mapping function S, comma F. Here Q set of state, sigma is the input alphabets. Mapping function is used to determine the next state of the given automata. S is the starting state and F is the set of final states. So define F is a set of final states. That is very, very important. See some formal definitions. This is my DFA, how DFA will be work. Input 0, 0, 1, 1, 0, 1 we called. So current input will be based in each and every cell 0, 0, 1, 1, 0, 1. Now initially starting state of the automata is yes. Current reader input will be 0. If 0 is read, what is the next state? Automatically next state will be again yes. Tab get moved to right hand side. Now current state will be yes. Reader input is 0. The corresponding process will be carried out. The blinking transition functions, the transition function will be represented now. Again, the next state will be yes. Tab get moved to right direction 1. Now current state is yes. Reader input is 1. The transitions will be goes to state F. And again F is transition. So F is input is transferred to, so input is change your next one position. Now current state will be F. Reader input is 1. If F comma 1 mapping function control is transferred to the automata is transferred to the state from S F to S. Now current state is S and read input is 0, S comma 0, keep as it is in the same S. S1 means goes to Y F. Finally, the input everything will be completed. Now current state will be F, which is nothing but final state. It will be answer. Suppose consider the next input 0, 1, 0, 0, 1. We start with S, 0, automatically control transfer to S. Next one, S comma 1, output will be F. Now F comma 0, output will be F. Again F comma 0, next state will be F. Now input 1 and F comma 1 is equal to move to S. If all the inputs are completed, what is the next state? There is no element in the input. There is no further input parsing. Now current state will be yes. It is not a final state. It will be rejected. So in this way, the input are parsed and finite automata will be work. So how it will be configured? So definition of automata F equal to Q sigma mapping function S comma F. A deterministic finite automata configuration will be current state and current input symbol. It's produced the transition diagram. It will be produced. This is the way they are representing their transition diagram. So similar example will be again repeated. Now consider the example of how the input is parsed in terms of derivation steps. The same concept. Similarly, current state will be S. Current reader input is 0, 0, 1, 1. So now S comma 0. What is the next state? The mapping function S comma 0, 1, 1, 0, 1. Now S0 means what is the next state? Same state will be present. 0 is completed. Now remaining input 1, 1, 0, 1. Now S1 means goes to F final state F, remaining 1, 0, 1. Now F comma 1 state will be changed to S, remaining input 0, 1. Last character will be 0. S0 na 0. S1 means F, it will be accepted. Similarly for next steps. 0 steps or more. So similarly for n number of states, it will be appear. So yielding 0 or more steps means S0 means its derivations will be in terms of n number of steps. Simultaneous work will be completed. So S0 we called for S and the 1, 1, 0, 1 means S comma 1 means F will be changed, remaining 1, not 1. Now F comma 1 goes to S, again 0, 0, 1. S 0, 1 means S 0, 1 means it goes to final state, it will be accepted. So that is concept of 0 or more steps for their processing. Similarly for another example. Next, we consider the example of DFA. So in this diagrammatic representation is transition diagram. This is our current state. So current state reader input. Suppose Q0 0, what is the next state? Q0. Similarly, Q0 1 means Q1 is the next state. Now Q1 0, Q2 is the next state. Q1 1, Q0 is the next state. Next Q2 0, Q1 is the next state. In terms of Q2, 1 is reader, Q2 is the next state. So now nothing but current reader is state, current state. This is reader input symbol. That means next input reader symbol. In terms of Q0 state, next input will be 0 is reader, means automatically control or automata is transferred to Q0 state. Similarly, Q0 state 1 is reader, Q1 is the next state. Q1 0 input, Q2 is the next state. Q1 1 Q0, Q2 0 Q1, Q2 1 Q2. So in this way, the deterministic finite automata is calculated and constructed in the manner. One more, keep it in your mind. So whatever the automata is designed, when the automata is defined that is a deterministic means for each and every state in the given automata, Once read the one input as a processing means it will be produced exactly one next state means the automata is called as deterministic finite automata. Not only for one particular state, it will be concentrate on each and every state in the automata. So all the states, everything is one input is reader a sample, automatically it will be produced exactly only one next state means the automata is called as deterministic finite automata. That's all about today's discussion about finite automata and their definition, simple examples. That's all about the automata introductions. Thank you for listening.